Hello, who am I talking to right now? Statistics. That's right. I'm talking to my statistics people right now. Good morning or afternoon to you. Today we are talking about another type of random variable, the binomial random variable. All right, so we've done discrete random variables. We have done continuous random variables. We've done random variables that are uniform, that are normal. Time for another one, the binomial random variable. So today we're going to calculate some binomial probabilities by hand, some simple ones. Eventually, yes, the calculator does do this for us. But I want to show you the basics so you can see where these numbers come from. Okay? So if you haven't seen it, I want you to go over to Teams and take the fake pop quiz. All right, go take the fake pop quiz and see how many questions you can get right. You are just guessing. There's no way to get a good score on this. All right, so pause the video, go take the fake pop quiz. All right, hopefully you're back. Hopefully you took that quiz. This is an example of a binomial random setting. Okay, taking that fake pop quiz where you just have to guess and you have a 1 in 5 chance of getting each question correct. You have no idea how to pick an answer. You have a 1 in 5 chance of getting a correct answer each time. And you do that over and over and over again. So I'm curious, did anyone get 0 questions correct? Raise your hand. Come on, raise it. Did anybody get 0? Proudly raise it 0. Did you get 0? So what are the chances that somebody takes all 10 of those questions and doesn't guess a single one right? Do you think that's a high probability or a low probability that someone could get 10 answers wrong from guessing? Well, let's figure that out. We can do that mathematically. All right, so in order to get 0 questions correct, they have to get the first question incorrect, right? We'll call that a failure instead of a success. Then they have to get the second one wrong, the third one wrong, the fourth one wrong, the fifth one wrong, the sixth, the seventh, the eighth, 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. They have to get all of those wrong in a row. So what are the chances that they go failure and then failure and then failure and etc.? All right, I am emphasizing the and there because we know what and does. How do we do probability with and? And means multiply. So we have to multiply these probabilities together. Blank and then blank and then blank. All right, so what is that? Well, you have a 1 in 5 chance of getting it correct, which means there you have a 4 out of 5 chance of getting it wrong. So this is 4/5 times 4/5 times 4/5 times 4/5. All right, I'm getting lazy here. Isn't there an easy way to write this? A much easier way? And there is, of course. That is 4/5 to the 10th power. They have to get all 10 questions wrong, and they had a 4 out of 5 chance of getting each one wrong. So we just do 4/5 to the 10th power. You could convert that to decimals if you want. 4 over 5 is 0.8. So you could also do 0.8 to the 10th power. Will also give you the same thing. All right, let's pull that up. So 4 divided by 5, raise that to the 10th. You do need to put the 4/5 in parentheses or turn it into a fraction somehow. You can't just square the numerator. So parentheses are necessary there. 0.10. Wasn't there a 7 at the end? 0.107, yeah. So almost 11% chance. All right, there was an 11% chance that somebody would get a 0. So I'm guessing in a class of 25, there's maybe 1 or 2 of you, maybe 3, that got a 0. I'm really curious. Were there about 2 or 3? Raise your hand if you got a 0. See how many of you there were. There should be. I'm expecting, expected value. I'm expecting in a class of 25, 1 or 2 of you, maybe 3, to get a 0. All right. Well, anybody get a 1? All right. You didn't get a 0 at least, but you got a 1? Did any ones out there? What are the chances of getting one correct answer? All right, now it gets a bit more complicated, but it's the same idea. All right, how do you get one correct answer? Well, it's possible you get the first one correct. So you have a success, S for success. But then you get all the other ones wrong. Failure, 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 failure. 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. But that's not the only way. You could also get the first one wrong, and then the second one correct, and then all the other ones wrong. But that's not the only way. You could do the third one correct. All right, I'm not. Don't worry. I'm not going to do all of these. Okay, I'm not going to do all of these. All right. How many combinations do we have here? If I were to do all of these down, all right, the success would jump from here to 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 here, and we would have 10 different combinations. Okay, they would all have 10 different combinations. What is the probability of each one of those happening? All right, let's take the first one. I'm going to rewrite this somewhere else, I think. Sorry. What are the chances of this one happening? Well, there was a success. What are the chances of getting one success? Of that first one being a success? That is 1 out of 5. They had a 1 out of 5 chance times now failure, 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 failure times 4/5. But now there's only 9 4/5. The next one is the same. All right, you have a 4/5 right here. Then you have another 8 of them. So there's 9 4/5 and 1 success. That one is also 1/5 times 4/5 to the 9th. Same thing here. We have 9 failures and 1 success. So that one also has a 1/5 times 4/5 to the 9th. So each one of these, let's figure out what this is. 1 divided by 5 times 4 divided by 5 to the 9th power. So each one of these has a 0.0268 probability. This one also has a 0.0268 probability. This one also has a 0.0268 probability. And there's 10 of these. There's 10 different ways this could happen. So my total probability here is 10 combinations times 1/5 times 4/5 to the 9th. That will give me my total probability that this could happen. Getting one correct answer. All right, let's figure that out. 10 times 1/5 times 4/5 to the 9th power. So there's a 20.268. So there's a 26.8% chance that you will get 1 out of 10 correct. And I'm guessing quite a few of you got only one answer correct. I actually have this data for a couple of years now. Let me pull it up. So here are all the numbers that people got correct. And here's the histogram here. So you can see most of us are between 0 and 3 answers correct here. All right, most of us are between 0 and 3. So I'm guessing a lot of you got one answer correct there. All right, let's do another one here. What is the probability of getting exactly 2 correct answers? All right, we're going to shorten this. Don't worry, stay with me. So you could get the first 2 correct, right? Success, success. Then 8 failures. 4, 5, 6, 7, 8. All right. Now, what are the chances of that happening? Well, we got 2 successes. So that is 1/5 times 1/5. So that is 1/5 squared. And then we have 8 failures. So that is 4/5 to the 8th power. Now, that's the chances of that one combination. But how many combinations are there to get 2 successes? Oh my goodness. I could go success, failure, success, success, failure, failure, success. Oh my goodness, I don't want to do that, right? But all we need to do is figure out, all right, I need the number of combos, okay? And then I will multiply that times the probability of each of those combinations happening is 1/5 squared times 4/5 to the 8th. However many combinations there are, I multiply by that. I'm curious, how likely are each of these? So 1 divided by 5 squared times 4 divided by 5 to the 8th. So yeah, less than 1%. There's a less than 1% chance that each of these combinations are going to happen, but there's a lot of combinations. There's a lot of ways that you could have 2 successes in 10 tries. So how do we figure that out? Well, there is a formula. All right, it's going to look kind of scary at first, but stay with me. It's actually not that bad. It's called the binomial coefficient. Okay? And there's 2 ways to write this. You could write it this way, NCX. That stands for choose. The C stands for choose. Or N over X. No division bar, though. And this is going to tell us how many combinations there are for a certain scenario like this. Okay? So let me show you how to plug in everything here. We have a new operation for many of us, I'm guessing. The exclamation point is a really cool mathematical operation. Okay? So the N is the total trials. So we are doing 10 questions. So that is going to be 10 for our example. X is the number of successes. How many successes are you trying to get in those total trials? All right. And so for the one that we're going to do, the way we would write this is 10 choose 2, right? We're doing 2 successes. 10 choose 2 times 1/5 squared times 4/5 squared. Another way of writing that, you'll see, I think when you do your Khan Academies, Khan does it this way. Khan does it like this. He's like, hey, 10 choose 2. It's not a fraction. 10 trials, you want 2 successes times 1/5 squared times 4/5 to the 8th, sorry. Okay. All right, now how do we plug everything in? All right, so off to the side, I'm going to do that here. So my formula is n, this is called factorial, over x factorial times n minus x factorial. So factorial is a really cool thing. Let's plug it in and I'll show you how to do it. So it's 10 factorial on the top over 2 factorial times 10 minus 2 factorial. All right, let me write that weird word. The exclamation point is called factorial. And it means to multiply all the way down the number line. So 10 factorial is 10 times 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2, and technically, yes, times 1, even though that doesn't do anything, over 2 factorial times 10 minus 2 is 8 factorial. It's kind of a cool operation. You multiply all the way down. 10 times 9 times 8 times 7. It gets big really fast. It's a kind of a cool operation. Okay? All right, so we got to figure out what this is. Now, you could type it into the calculator, but because the numbers get so big so fast, your calculator doesn't like it actually. But you can cancel things out a lot of times. So if we recognize this part right here, well, that's 8 factorial, isn't it? That's 8 factorial right there. That's 8 times 7 times 6 times 5 times 4 times 3 times 1. This one down here is also 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. So that cancels out right there. So what we're left with is 10 times 9 on the top. And on the bottom, we're left with 2 times 1. So we're left with 90 out of 2, which is 45 different combinations. There are 45 different ways that you could get 2 answers correct. And so, oops, there we go. We now know this is 45 times 1/5 squared times 4/5 to the 8. And that will give us the probability of you getting 2 answers correct. So 45 times 1/5 squared times 4/5 to the 8th. So there's a 30% chance. You've got a 30% chance of getting only 2 correct, which is why I'm guessing a lot of you got 2 answers correct on that fake pop quiz. All right, let's do one more here together, and then maybe I can have you try some out. Let me see how long my video is getting here. What am I at? 18 minutes? All right, yeah, it's getting a little long. I'll try to wrap this up for you. All right. So what is the probability someone will get? Let's do a new question. Let's do another question. All right. After warming up, Bolt has a 32% chance of making a cornhole shot. Yeah, cornhole. All right. I got a 32% chance of making a cornhole shot. I'm going to take 20 cornhole shots. Okay, 20 cornhole shots. What are the chances I make exactly 5 shots? All right, so my chance of success is equal to 32%, 0.32. My chance of failure is equal to, let's see, if I have a 32% chance of making it, I have a 0.68% chance of missing it, right? They have to add up to 100. All right, so what are the chances I make exactly 5 shots. That means I have 5 successes. So I had 5.32s. 5 successes. Times, all right, how many misses did I have? 0.68 to the, I had 15 misses then, didn't I? And 15 failures. 5 successes, 15 failures. The question is, how many combinations can I do that? I could go make, and then 15 misses. I could go make, miss, make, and then all misses, right? There's so many combinations. How many combinations are there? Well, the way we first write that, it's 20, choose 5 successes. All right, that's the way Khan writes it. You could also write it as 20, choose 5 as well. So we just got to figure out what that is. All right, so over here off to the side, we're going to do 20, choose 5. That will be 20 factorial over 5 factorial times 20 minus 5 factorial. Okay, so now we got to do this multiplication here, but it simplifies a lot. So if you imagine we've got 20 factorial on the top, 5 factorial on the bottom, 20 minus 5 is 15 factorial. Well, a lot is going to cancel out between that 20 and 15, right? So what's going to be left over in the top? We're going to be left with 20 times 19 times 18 times 17 times 16. But then 15, 14, 13, 12, 11, 10, 9, 8, 7, 6, 5, 4, 3, 2, 1 is going to cancel out with this 15 factorial. So the rest of it is going to cancel out, so I don't have to write it. Divided by 5 factorial. 5 times 4 times 3 times 2 times 1. All right, so that is actually what this is going to boil down to. That's not that hard to do. All right, so 20 times 19 times 18 times 17 times 16. That's going to be a really big number, right? Woo! Divided by, I think I need parentheses here. 5 times 4 times 3 times 2 times 1. All right, so I'm left with 15,504 combinations. 15,504 combinations times 0.32 to the 5th times 0.68 to the 15th. So multiply that times 0.32 to the 5th times 0.68 to the 15th. And I have a 0.159, like a 16% chance, which is about 16%. There's about a 16% chance that I'll get 5 shots exactly. All right, that's how that works, everybody. Hopefully that's making some sense. I've got 2 Khan Academies for you to try out that sort of walk you through that process again. Okay, so try those 2 Khan Academies, see if this is making some sense, and I hopefully will see you all tomorrow.